Okay, so question 1 is, for 0 is less than or equal to t, which is less than or equal to 6, a particle is moving along the x-axis. The particle's position x of t is not explicitly given. The velocity of the particle is given by v of t equals 2 sine e to the t over 4 plus 1. The acceleration of the particle is given by a of t equals 1/2 e to the t over 4 cosine e to the t over 4, and x of 0 equals 2. The first question is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. So right here we are looking at the speed of the particle when the time is 5.5. Remember though, speed is not velocity. First we must figure out what v of 5.5 is. We would just need to plug in 5.5 to the velocity function. They already give the function to us, which is v of t equals 2 sine e t over 4 plus 1. Since we need to plug 5.5 to find the velocity of it, we would just put in v 5.5 equals 2 sine e 5.5 over 4 plus 1. Since this is a calculator problem, we only have to plug it into the calculator. Since I don't have a calculator, I had to use Mathway, but either way it does the job well. So I plug it in, and the answer will be negative 0.45337. You only need 3 decimal places, but you know, it's just for sure. So right here we see the answer to the v of 5.5 equals negative 0.45337. So the answer, once plugged into the calculator, would be negative 0.45337. But that, remember, this is speed, not velocity. So based on the negative number after plugging in 5.5, we know that we are going to the left, but not if we are speeding up or not. Now check acceleration by plugging in 5.5 to the acceleration function. Here they already gave us acceleration, so the only thing is to put in 5.5 into it. So the acceleration function is a of t equals 1/2 e to the t over 4 cosine e to the t over 4. And pretty much when we plug in 5.5, it will be a of 5.5 equals 1/2 e to the 5.5 over 4, which is cosine e 5.5 over 4. And after that, because also since it's a calculator problem, we could just plug it in. Once plugged into the calculator, you will see that we get negative 1.35851, which is the answer to the acceleration of a to the 5.5. Because both v of 5 and a of 5 are negative numbers, we can conclude that they are increased. The speed is increasing since it is stated that velocity and acceleration are the same sign, is increasing. If they are opposite signs, is decreasing. So pretty much the reason for our answer that the particle is increasing would be that the speed is increasing since the velocity and acceleration have the same sign. Okay, so B is find the average velocity of the particle for the time period 0 less than or equal to t, which is less than or equal to 6. Pretty much what we need to find next is the average velocity, obviously, which we have been given the function. Knowing average value formula using V, it will be in which we care to know the average velocity from 0 to 6. So by plugging it in, it will be 1 of 6. We will be able to plug this in the calculator, but first of all, we got 1 over b minus a, because b is 6 and a is 0. So obviously it'll be 1 over 6, and you plug in the boundaries, which is 0 to 6. When we plug that in a calculator, we will get an approximate value of 1.949. So the average velocity will be 1.949. So C is find the total distance traveled by the particle from time t equals 0 to t equals 6. So the distance traveled is found by the integral of 0 to 6 of absolute value of v of dt. So pretty much for C, we're going to have to plug it into this formula, which is, well, not the formula, but I'm already plugging in some of it, right? Which is the absolute value of Vt dt, which will equal distance. This is already our boundaries, so but we already know that we have to plug it in there. So pretty much after we plug it in, it'll look like this, which is once you plug that in, since it's a calculator problem, we need to just plug in the calculator, and what we get is 12.573, which equals our distance, pretty much. Since I don't have a calculator and I already did the work before, I can't really show it, but once you plug in this in, it will become this. So as you can tell, we already graphed it, and the point that it changes, what's it called? Direction is that it goes from positive to negative, and we see that's 5.16. But since I already graphed it before, I got 5.19552 to put more exact. But once graphing in here, it gave me 5.196. To find the position of the particle, we must integrate to go from velocity to position. So pretty much when we already graphed it, we got 5.552, and so when we do the function we're gonna have to put in is this one. That's the function that we're gonna use to finally find the position. And pretty much when we plug it in, it's gonna look like this. And remember, once you find this on the calculator, you have to add 2 because the 2 was a starting point. So after that, once we add the 2 and everything, the answer will be 14.134. And pretty much that will be the starting point that, what's it called? That will be the position of the particle at that time. Not the starting point. The position of the particle at the time.